This video we are working on graphing systems of two linear equations in two variables on a coordinate plane. So otherwise we're going to have two equations, whether they're in standard form or the slope-intercept form. Alright, don't forget the slope-intercept form looks like this. It's y equals mx plus b. Alright, so we want to solve for y for both of these. So we're going to take one of them and we're going to go ahead and get started. We're going to take question number one here, and I'll go ahead and put it here. X plus y equals 4. Now remember, I want to solve for y. So I have to ask myself, what's being done to y? Well, it's being added by x. Now, when we say add by x, we're talking about the sign in front of the x. So it's really nothing there. So because there's nothing there, we know it's a positive. Just like if you said, somebody asked how old you were, and you said you're 20, you are really saying you're positive 20. Alright, so we do the opposite to both sides. So I'm going to subtract x to both sides. Now I can't subtract a 4 and an x from a 4, so I just write it out what we see. But if you notice right here, I got plus, and I'm talking about right here, plus x minus x. That's called a zero pair. Alright, and so that kind of like means it's 0, it's gone. We're going to bring down the y, and we're just going to write out minus x plus 4. Now I could write 4 minus x, it doesn't matter. Alright, so we're going to go ahead and graph this now so we can kind of get it. We're going to do it in black since I have it in black. Alright, when we graph these, we're looking for the slope and the y, slope and the y-intercept. Remember, this is the y-intercept. And the number in front of x is my slope. The represents the slope. Alright, so I'm going to go to the y-intercept where it's 4. 1, 2, 3, 4. So there's my y-intercept right there at 4. Alright, my slope is a negative 1. We don't see a number there, but we know there's an imaginary 1 there because how many x's did you see? 1. And so there's a negative 1x. Which, if we know we have a negative 1, that means my change in y was a 1 and my change in x was a 1. And one of them was a negative. It doesn't matter which one, but one of them is. So if we're thinking rise over run, we know that we're going to go down 1 and over 1, and I'll put a little dot there. Down 1, over 1, to dot there. Down 1, over 1, down 1, over 1. So I kind of like to go until I get to the intercepts. Now, remember, I could go down 1 to the right 1. I also could go up and to the left, because as long as I make one negative motion, then my slope is negative. And when I draw this, does it look like my line is going down when I go left to right? It should. Alright, so we've got that one. And so now we're going to do the other equation. So I'm going to go ahead and erase this. So, and I'll do it in red. Alright, so the other equation is 2x minus y equals a negative 1. Alright, again we want y by itself. The sign in front of 2x is a plus, so I'm going to subtract 2x to both sides. When I do, this becomes a zero pair, and I bring down my negative y. And then I have a negative 2x minus 1. Now, remember what we said before, or you should know that you cannot have a negative variable. I mean, you can't have a negative y equals this. So what you really do is you divide by a negative 1 to everything. So when you do this, it actually changes it to its opposite. So instead of a negative y, it's a positive y. Instead of a negative 2x, it's a positive 2x. Instead of a negative 1, it's a positive 1. Alright, so I'm going to graph this now. My y-intercept is 1, so I'm going to put a dot at 1. My slope is 2, so that means I go 2 over 1, and that means my rise and then my run. So I'm going to go up 2, over 1, up 2, over 1, up 2, over 1. I could go down 2, left 1, down 2 to the left 1. Oh, I only went down 1 and went to the left 2. I go down 2 to the left 1. Alright, and then I'm going to draw my line this way. Alright, so this is what we're really looking for. Alright, so we're looking for where the two lines intersect. This is called a single point solution. A solution in linear systems of equations is when how many times they touch. And this solution is a single point because they only touch one time. They intersect. And that intersection is at 1 and 1, 2, 3, and 3. So this is 1, 3. That's the point of intersection. And if we put those points in for like X and Y, it should make both of them work. So it should work for both of them. So otherwise, it's true for both of them. So here we go. I'm going to do the first one. X plus Y equals 4. So 1 plus 3, does that equal 4? Yes, it does. All right, the other one is 2x minus y equals a negative 1. So if I put the values in, that's 2 times 1, which makes 2. And then I got a minus 3, so 2 minus 3, does that equal negative 1? Yes, it does. And so you can see that this is our point of intersection. It's a single point solution for this equation, for these two equations.